Previously on The Bald Engineer.
Really? If it's fixed, then we fixed it. Yeah. What? Thank you so much. Woot indeed. Hey everybody, welcome to the stream. All right, had a couple of false starts there. Going to, let's see if I can fix that. Yeah, give me 1 second. Let me just do this. Wow, that's messed up. Okay, that's not gonna work. I moved my camera and forgot until I hit start stream, so I was like, whoops. Let's do this. Actually, that shouldn't be showing up. It's because it's this one. Okay, whatever. Let's get going. Get out of here. Hey, everyone. Okay, so we're going to be doing... Oh, wow. That's not what I meant to do. That goes over here. Okay. So we're going to continue working on the MC-10 schematic. We have... I think today will be our final day with it because we're getting pretty far in it. So I'm still using release candidate 2 for version 8. I was hoping by now the new release candidate would be out, but it's not here yet. I understand there's going to be at least one more. So, okay, fix this. Nope. Do that. Okay. All right, so we got that, and now I'm missing my reference document, which I put up here, which we're using from waveguide.se. Oh, KiCad or Windows, I'm not sure who to blame there. All right, and then let's close that. Okay, let's make this a reasonable size window because we'll need to come back here at some point. Okay, there we go. Much better. Now we can get to work. Okay, so where are we at? I think CPU, ROM, some latches, video chip. What else is over here? Yeah, so I think we'll just keep going in this direction because let's see, where is U4? U4 is here. Okay, I'm going to, what was I thinking about doing? Nope, I don't remember. Okay, so I think what we're going to do is we're going to do U5, 6, 10, and 9. Let's get those put into the schematic, and then that will actually take care of a big chunk of the chips. So yeah, so let's just put those in because these are all bust anyway, so it shouldn't be too hard to connect them up to stuff. So we'll make this a little more bigger. Nope. Let's try this. Yeah, okay. Just thought of how to do this. No, that's why that doesn't work. Okay, never mind. I can't remember how to move mini-me. Okay, so what is this? This is a 74 LS367. So there's a couple of things I was actually wanting to try. We'll take a look at those later. Let's do a 74 LS367. Jeez. All right, and the pins are totally not laid out. Okay. So I've had a change of heart. When we're done, we're going to go back through and I want to remove custom standard parts from the MC-10 library. And what I mean by that is, so like, for example, and I'm going to do it on this one, we're going to modify this symbol in the schematic. I don't see a reason to add it back into its own library. It doesn't matter. But the processor and the video chip, even though those are off-the-shelf parts, I think we'll keep those in their own library because that might be useful to another project. I don't know. Just a thought I had while I was looking through something else. So, okay, so just like we've been doing, what I'm going to use is the properties panel. And we'll put the inputs correct first. So we'll go pin 10, pin 12. This should be 50 mils. Pin 12, pin 14, pin 2, pin 4, and pin 6. All right. And then over, no, let's get the names. So the names actually, yeah, we'll rename them. This will be the same. So it'll be 1, 2, 3, 4, pin, and I want 5 and 6. Yas. Okay. So on the outputs, we'll go 9, 11, 13, 3, 5, and 7. All right, and we'll go ahead and move the ground to be over here, just like they're doing, because for sure, why not? And the enables, I'm actually gonna, yeah, okay, we'll move them. Why not? It hardly matters. Except, what is going on? Why is the grid off? Dun dun dun. What's going on here? That was weird. That's suspicious. All right. And then I'm going to move these down just a little bit because that's how they are in this schematic. So that might matter. So we'll do a save, and then we can close this. So now we've got our semi-custom symbol, which is the same on both of these. Cool. All right, so this will be U5. Let's scrunch this over just a little bit. All right, so we'll go U5. Hey, Francois. Happy, I guess it's Friday for you. Let's do an A. Nope. Do an A. All right. And then, oh, I see what they did. Okay. So what we're going to do is we're going to copy paste this quickly. Interesting, they didn't draw a decoupling cap with this component. That's suspicious. All right, let's move you into the middle. Let's move you into the middle. And then let's do a wire out to about here, and then insert that a bunch of times. And then we'll do a wire to here and insert that a bunch of times. And then we're going to do, let's see, does this go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that works. So A, no. Let's go for label. A0, and then I'll insert this to get pressing, wait, that's text, my bad. I want it a label. A0, there we go. Wait, that still looks wrong. Oh, because it's A, duh. 6, 7, 8, 9, 10. I forgot, I color coded the address stuff. All right, so then we're gonna do a Y to flip that upside down. And then we can just grab these guys and put that right here. I'll put these right here. When you redraw schematics that are pre-digital workflow, how far do you go to match unusual symbols versus a more modern updated schematics? Oh, so yeah, I get what you mean. Like if they're using, I can't think of something off the top of my head, but like there's some really odd ways that capacitors have been drawn, like in hand-drawn schematics. To me, in general, I think it's more important that you're consistent in the schematic, and it's less important how much you like hold to the original look of the old one. And so Like in this case, like in the case of this particular schematic, I am using a lot of its conventions because this is already nicely, cleanly laid out. But like when I was doing the Apple II schematic, I did a lot of like, well, this blob, I mostly followed the schematic as is, and this blob I mostly did, but then these two blobs I rearranged. And that was just because I saw ways to sort of optimize it, especially knowing that it was going to be like a digital schematic. So I think it's, yeah, so I think it's more important that you're consistent and, you know, do what you need to make it match what, you know, just make it readable. So I mean, let me back up and give an alternate answer. It really depends on what your intention is. You know, if you wanted to make a schematic, a recreation of a vintage schematic that was, you know, faithful to the whatever you're redrawing, then you might go through the effort of redrawing the custom symbols. But to me, the primary reason that I started redrawing these schematics was just that I wanted them to be readable and usable. And so that's where my focus is what can I do to make it usable and readable in a modern workflow. You know, it's like stylistically, I'm not wrapped up on, is this a one-for-one copy of the schematic I'm recreating? And so the final footnote would be, if I had something like, I don't know, like a poster or something for like some kind of famous thing, I could see trying to make it much more faithful to that. But like redrawing a repair schematic, I don't know. I think it's just important that you capture the information. Yeah, you use common sense. And like I said, it's more, no matter whatever you decide to do, it's more important that you're consistent, because that will make it readable to other people, right? It's much easier to read something, even if you don't agree with somebody's conventions. If they're at least consistent in the diagram, then you can read them. You can figure it out, right? And to me, that's the really important thing. I mean, like, oh, okay. Here's another sort of example. Is I very often will just use labels in the redrawn schematics, like I did it over here. So here's a reset signal, and then reset was somewhere over here. Oh, I ended up drawing a wire anyway. But you know, like this is an example where in a lot of these older schematics, I don't redraw unnecessary wires because I think it makes it harder to read the schematic. And in a modern usage of the schematics, you're pretty rarely going to have them printed out on paper. And even if you plot this to PDF, you can still do a search for text if you use plot, not print. And so there's not really a strong reason to have a lot of wires, except for when not to have a lot of wires. Like I prefer to leave wires in when it just makes things more clear. But that's I think that's really a style choice. Anyway. Oh man, I forgot I reloaded the window, so now I have to get rid of the reaction thing. Hold on. You can't see what I'm doing. I appreciate that YouTube has the little reaction button that people can press, but I don't understand why as the streamer I have it, because it blocks messages. Hey, Tamaz. Yeah, I mean, I've been on YouTube for like 10 years, so you know, I've been live streaming. Well, I've been live streaming back on YouTube on this channel for the past year. It's been about a year. No. A year ago is when I stopped. It's been 6 months, maybe 6 months. But yeah, been doing live streaming on this channel on and off. And then in terms of uploaded videos, I have a bunch of videos on the Element 14 community channel. In fact, I think I'm up to 82 Workbench Wednesdays episodes. Yeah, my goal on that was I had hoped to get to 100 and then just be like, I don't know what to do now. All right. But most likely starting, let's say, sometime in March, I'll start uploading videos to YouTube again. Like right now, I am working on a video for the release of KiCad 8. So I'll have something to talk about my favorite features. It's a really clever, well, I came up with a really clever title. I think it's clever. And I've got it written out. I just need to do the screen grabs and then well, just well, so I've drafted a script for it, and then now all I have to do is make the video. Let's move this over, and then let's add a test point. And then let's go visible, and then we'll make this test point 1 to almost miss that. All right. Okay, and then both, oh, these are both buses. And I named these wrong. So let's do this. Just delete these. All right, insert to copy those. Let's draw a new one. Remember, the insert key repeats the last command, which is usually draw or insert something. And so on the label, I'll do a VA0, and then I'll just hit this 10 times. Maybe one more, right? Because this goes to 11. Yeah. So then I'll use Y to flip them upside down and X to flip them that way. And then we need up to number 5. So we can put that down here, and these we'll put over here. Okay, that's better. Hey, Jack. You can actually watch the streams after the fact. There is a playlist in the playlist tab called, get this, live streams, and they appear there. It's really annoying. Unless you have a plugin, they're out of order. I wish they would I wish it was the newest one versus the oldest one, but whatever. Let's do this. Okay, and then I think this is where I want it. Nope, that's where I want it. And then we'll insert that a bunch of times. All right, let's delete this one. But I have thought about, so if my plan this for 2024 happens and I start getting back, well, not if, when I get back into a regular posting schedule on this channel, I probably will create a second channel for things like the live streams. I personally don't like it when they show up in the feed, unfortunately, and I don't know why. But every single time I let a live stream get published, I get a bunch of comments about people complaining that I'm taking too long to get to the point, that the intro is really long. Why don't I make it shorter? My favorite ever was, you American vloggers, all you do is talk. You never get to the topic. And it's like, I put archived live stream in the title. I put live in the thumbnail. I used to even would have it like, I think at one point I even had like a thing come up at the beginning of the live stream that said it's recorded, and then I would tell people it's not recorded. For a while I thought about trying to say like the current date. But yeah, no matter what, if it shows up in the public, if it shows up as a published stream, then for some reason, a vast majority of the population cannot figure out that it was a live stream, and it's just so I don't publish them. KiCad 8 the Ocho. A dodgeball reference. Nice. Okay. So, where do these enable signals go? Well, first, they connect to each other. So that's a clue. And I'm going to guess they must connect to some of the logic that was over here. Nope, they go somewhere else. Shoot, I lost it. Okay, it's this line right here, and then it comes up here, and then it's this line here. Okay, so that's going to connect to, I'm going to do the same thing I've been doing on these others. I'm going to add a label just so that I can find it later. U11, and it's pin 12. This is actually something I got from the Apple II schematic. They did this quite a bit, where some of the nets, they would just say where the signal was going with the newspaper of the day. Well, that's why, I mean, I used to, I'm saying this like I did for sure, and now I don't actually remember. But I used to say the date in the live stream, and that, I don't know, I don't get why people complain about stuff. I just don't get it. It's like, I mean, if you've got something constructive to say, that's useful, but never mind. I'm just going to start ranting, and I don't want to find the rant button, which I don't think I've actually assigned it on here yet. Yeah, I need to, actually, you know what I need to do is I need to bring my stream deck from the lab up here, since I probably won't be streaming from the lab anymore, or at least not often enough to need the big stream deck down there. All right, so then that connects to the address bus. So where's our address bus at? The nearest one is right there. So I think what we're going to do, number one, make this page bigger. I want more bigger space. Okay. More space is better. All right. And then we're going to move this up a little bit. And now I will go bus this to here. All right. So that's the address bus. And then the video address bus goes to U10. Wait. Oh, I see. So it goes over to, yeah, so that goes all the way over to the video chip. Imagine that. So here's what we're going to try. I'm going to grab all of this. I'm going to hit G and move it up quite a bit. Bring this back down. Whoa, what are you doing there, buddy? Bring that back down. So what I wanted to do was sort of do something like this. And then we're going to move this label down here and delete that. All right, let's try that. It goes to 11. So back in COVID, I used to joke how, what if all this streaming stuff was just in my head and that there wasn't even a camera and I literally was just sitting in a room talking to myself? Like, you know, which is even better because I'm almost finished rewatching Mr. Robot. I've been playing it for, I guess, actually probably since the last stream. I've been playing it in the background as my work noise. And yeah, that kind of makes me think of Mr. Robot. All right, let's save that. Hey, Commodore, good to see you. Okay, so is there a 4016 in here. That is not what that is it? No. Yeah? No. 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 No, 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 no. All right. I feel like this is like something to do with, why is it like a micro P 4016? UPD 4016. This is the RAM? Oh. Oh my. Oh my my. Oh my. Oh my. Oh, I called that wrong. I was thinking this was like a, I actually did think it was an analog switch. Let's see if we can find a better data sheet. Nope. Yeah, this is a better copy. Nope. Yeah, actually, I just started the last season today. And is it season 4? No, season 3 has the episode where they shot it like it was one long take, which I really love watching because I think I found all of the parts where they stitched together multiple scenes. But it's still done amazingly well. I mean, for a TV show to pull that off was crazy. But yeah, like the whole episode, there's never a hard cut for the camera. And so it's effectively shot in real time for the event of the episode. And then season 4, the last season of Mr. Robot, does have another awesome trick where there's only 2 sentences verbally used throughout the entire episode. And it starts with the scene opens with one of the characters saying, "It's okay, we don't need to talk," and then it ends with, "We're good now." And but that's it. It opens and closes with a sentence, and then the rest is all played out with like mostly text message kind of things and reading stuff on screen. But I remember when I first watched the episode, I got like, I don't know, 15 or 20 minutes in, and I realized nobody was talking, and I was just like, holy cow, this is crazy. And I remember it because it was sort of the same thing. It was like I was trying to I had it on while I was working on something, and I realized I couldn't look away because then I wouldn't know what was going on. So anyway, I forgot the name of that episode, but it's a really good one. I just like how they did stuff like that. So okay, that's a lot of words about a story nobody asked about. Need a Shelly 50 amp. Okay. Without seeing the schematic, I don't know how. I'm not confident in what double pole or dual pole means. I always have to look at the schematic to know. All right, I think we're just going to draw this. So let's go to... Can you get to... Yeah, let's go schematic editor right here. Filter library. We're going to look for MC-10 or MC-10. MC-10. New symbol. Symbol name will be UPD 4016. La la la. And then we will do a symbol name, keywords. Wait a minute. Where's the description? Oh, the description moved. I just realized that. The description's up here now. I think I think the last couple of symbols we've made for this project, we're going to check. By 8-bit static NMOS RAM. All right. I want to look at something really fast. So we're going to go MC-10. Well, okay. So this one I think I made. Oh, I just didn't put yeah. Huh. How about that? Yeah, I totally didn't realize they moved the description box to the field table. It used to be right here. Huh. How about that? How about them apples? Okay, so now we need a whole bunch of pins. And I can barely read this. Where's the thing to make it more bigger? There we go. Oh yeah, that's actually quite a bit clearer too. It's like a alias filter like kicked in or something. All right, so we're gonna go pin 1 through whatever, and then the address, of course, the address is gonna be upside down. Actually, I'm going to do it based on this. What is this doing? Because they may not be following the same pinout, and they're not. Okay. Okay. I'll use the data sheet though to, well, I probably don't need it. We'll see. So, yeah, so we're going to do address. Okay. So I think the best way to do this is I'll do a pin and I'll name it A0. It's an address, so it's an input, and then we'll add that to be 10. And then I'll do Y to flip those upside down, and then we'll just go one by one and change their pin numbers. So 19, and actually this might be a little bit easier to come in here since these are in an order. So this is 8, 7, 6, 5, 4, 3, 2, 1. No, I messed up something. 8, 7, 6, 5, 4, 3, 2, 1. Oh, I just don't know how to count. Okay. 23, 22, 19. All right. So those are taken care of. So why do they have these as I not O? Wouldn't they just be IO? Yeah, they're just bidirectional. Chip enable and output enable, so they're actually tri-statable. Okay. Oh, there it is. There's 21. Is that the write enable? Okay, hold on. There's a chip select. Oh, and then their output enable. They tied these low. Okay. Okay, so we're going to do 9, 10, 11. So close. All right, so let's do a pin. And this will be IO1. And I'll go ahead. We're not going to do that. And then we'll do left. And then so same thing. We'll do IO1. And then I'm going to do this until we get 8. And then use Y to turn them upside down. Oh, shucks. This is... Wait. I forgot. We can use this now. We can use the property. So I set these to input. I should have set these to tri-state. I forgot to set it before I hit insert to repeat. So I'm going to highlight them all and then use the property manager to set them to tri-state. Oh, yeah.
There was much rejoicing.
Yay. All right. Now we'll go back into the table and we'll give these pin numbers like 9 and 10, 11, 13, 14, 15, 16, 17. That was fun. What a fun little game that was. Okay, now I'll do an input, and this will be the not output enable, and that number will be 20. And that will go here. And then we'll do one up here for chip select. I wonder if that's inverted as well. I think that's pin 18. And then we'll come over here and we'll do write enable, which is 21. And I just find it hard to believe that those are not inverted. All three are inverted. So we'll do tilde and then put that in brackets. And we'll do tilde and put that in brackets. All right. Now let's move this and this out of our way for the moment. And then let's bring this in a little bit. Doesn't need to be so thick. All right. And then we'll, oh, something's wrong here. We need to rotate that one. Okay. So now we're going to draw a rectangle, a rectangle. All right. And let's go ahead and change its fill color to be, oh, nope. Ooh, fill body outline. Nope. Body background. Okay. So the middle of this part is, let's start with this one. Did I get that? No. No, no, no. Okay, let's move this over one. Is that still not in the middle? Okay, so now that's the middle. And then let's try this other way. So I think this is the middle. Nope. And if I move this up, that's not the right place either. Okay, so let's make this one click bigger. And now we're in the middle of the part so that it's more easy to do that. And then this we'll just put somewhere like over here. This we'll put up here. This we'll put up here. All right, now we'll get rid of these lines because we don't need those anymore. Whoops. There we go. Yeah, how about that? You know, I never use, I always forget this is here. There's like a little check that will check things. Okay, so we've got 21, the address lines, so 19, 22, 23, 1, 2, 3, 4, 5, 6, 7, 8, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 876 543 210. Output enable. Chip select, and I forgot ground and VD and power. All right. So we'll do a VDD pin 24, and this will be a power input. Right. And then we'll just rotate that and put that like up here. And then we'll do another pin, and that will be VSS, and that will be pin 12, and that's also a power input. And there we go. We have a 2K RAM chip. I think it was 2K, right? Yeah. Okay. And those are going to go right next to each other. Isn't that cute? Okay, we'll save this one. And then we can close the editor. Then we can come in here. I'm going to look for a 4016. There it be. And we can go plop, plop, fizz, fizz. Oh, what a relief it is. Yeah, that's nice. That is nice. You know what I haven't found yet? I haven't found any of the Git integration that is coming in 8. And it's not like, it's really minimal from the screenshots I've seen, but I don't know how to do it. I didn't realize there was the Python Terminal 4 schematic editor. Anyway. Okay. Now let's go U10. Edit 10. So then we need, so let's do label VA0 first, and then go all the way up to 10. Flip that, and then we're going to move this over here to about there. Draw a wire and insert a whole bunch of things. And then over here, we're going to have VD0. Oh, that's not what I want. Label VD0. Rotate it, although I should have waited on that. 6, 7. And then Y to turn it upside down. And we'll move that to be about here. And then I kind of want these lines to be about the same size, which I did. All right, so we'll draw one so that we can hit insert. All right, and now we're going to try and guess where the bus member will show up. Yes, I got it, first try. All right, and then over here, we got to rotate, and then I'll do that. And then we can do, whoops, one too many. Okay. Now, let's add a capacitor. So we'll do something up here. And then delete that. That's too much. So this will be number 25. We need a ground symbol. Put a ground symbol like right here. And then we're going to put one down here. And we'll put one over here. All right. So then, what's the next chip get connected to? It's also on the address and data bus. Is that really? That doesn't seem right. Huh. Okay. Well, here's what I should have done then. Just copy and paste this whole thing. All right. And then let's come over here and U9. Because that's 0 through 10. I'm surprised they're not like off by one address bit or something to be a different bank. I don't understand why you would do this. Oh, but they have different chip selects. Interesting. Okay. Well, in that case, whatever floats your boat. Man, I kind of want to do this. This is not standard, but I feel like this would be less lines. Electronics career path question. Uh-oh. I mean, I think regardless of technology field, and technology is things beyond just electronics and computers, but any kind of technology field. Remember, technology is the application of science. At some point, there's a level of abstraction that you just can't explain anymore. So like even in the case of an electronics, like electronics in let's say the 1980s or 90s, while you could say a Commodore 64 computer, one person can understand from the transistors on the chip all the way up to the pixels on the screen, the entire circuit and everything happening in between. But that's only if you abstract out a handful of things, right? Does that same person also understand the actual physical geometry and the nature of the transistors in the way that they were designed on the chips, or how those interact, or how they actually get used? There's probably holes in that understanding. And so there's always some level of abstraction. I think if we look forward to modern electronic devices, the idea of a person understanding an entire device is unfortunately just kind of going away because everything is too complicated. But arguably, it used to be a television set only had one input, right? It got signal from an RF signal that was very well defined. Now there's tons of different ways that a TV can get an input, not necessarily for content to display, but just different, they could have a Wi-Fi and Bluetooth radio on it, right? And so, you instead of I'm an expert on televisions, become an expert on 2.4 gigahertz radio transceivers or something like that, some piece of block, because no matter what, that abstraction is always going to happen. So that's probably the best I could answer that question with. I think one thing, and this is something that I'll speak for myself. I'm not trying to speak about you or anyone else. This is just me. Is I used to have an obsession with understanding everything. I wanted to know how everything worked from top to bottom, 100%. And over time, I've come to learn that that's actually not a very productive. It's actually not productive to try to be that way. Well, let me maybe a better way to say it is at all times. At some point, you have to allow an abstraction to happen because you can't understand everything. It's just at some point, the dam has to break. And so I think it's important to figure out what are those areas that you want to understand, right? Yeah, so that's why I kind of like the idea of instead, now you kind of focus on, well, here's a really good example is power supply. I would bet that many of the people who designed an Apple IIe understood the digital aspect very well, the way that you propagation delay, the way you tie signals together, how you map out memory maps, things like that. I'll bet a number of those people working on the digital side had zero idea how the switch mode power supply actually worked. At a high level, it's pretty simple concept, but when it comes to designing a really good switch mode power supply, that is something that if the same person designing the the hardware around the microcontroller is also designing a switch mode power supply, you're probably going to have some trouble, especially when you go to get your stuff EMI tested. So, but there's an example where it would probably be easy to say, well, and I think you could actually, arguably, you could say it's pretty easy to say, I understand how a switch mode power supply works, but to understand how to design one that functions very well in a certain application, that is not a trivial thing to do. So, yeah. Yeah, actually, backing up, Francois, when I bought my TV, I was kind of frustrated that I couldn't get anything that was dumb. I just wanted something that had a boatload of inputs. And then I made the mistake of letting my TV connect to the internet or to Wi-Fi, and it started downloading ads, which really irritated me because it was not inexpensive. There's no reason for it. And so then I tried to disable the Wi-Fi, and I can't. Once you give it a access point, there's nowhere you can go to delete it. So I just have it quarantined on my network. Well, like I said, so backing up, like I said, abstractions will always occur. I mean, even if we look, I'm using the Commodore 64 as an example, right? Arguably that has an abstraction already. Look at the chipset, right? The chipsets abstract out a whole bunch of logic that could have been discrete. It's just the nature of the beast. How many, that's another example I can use, is how many people that designed the Commodore hardware understand how the SID chip actually works. Again, you might get an idea on a block diagram of how the registers are implemented and how it makes noise, but that's an area that not many people know how to do well. No, my TV, I did the factory reset and it still maintained actually I take that back. Maybe that's what I ended up doing. Maybe I did a factory reset because it doesn't connect to the Wi-Fi anymore. I think that's what I ended up having to do, is I quarantined it and then I did a factory reset and I just don't let it connect anymore. Send back the Wi-Fi antenna. But yeah, the common example I use, because I see this happen a lot for some reason in electronics, and I don't fully understand why, but I see a lot of people, they'll get wrapped up in, they want to understand, they say they want to understand everything from top to bottom, but if you think about it, you really don't, because in order to fully understand everything, you have to really understand stuff like physics. And on an application level, there's no value in actually understanding how a field moves an electron around and what a charge carrier is. It's fun to understand it. I think it's cool to try to understand it, but it's like to do anything practical, it's totally not necessary. All right, I missed this not inverter, or inverter not gate. That's what I was trying to say. Not inverter is a double negative, I think. All right, so we need to add an LS14, which I could probably have copied one from over here because I'm going to stylize it. Oh, I didn't. Oh, okay. And I forgot to number that one. Okay, I'll worry about that later. Okay, so let's come up here. Let's go edit. This is going to be number 12. And I want unit probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably the last one. Off by 1. Okay. Oh, actually it's a 14, so it's a Schmidt trigger. Same thing, it's still an inverter. Okay, so that's going to come out to here. And then that will come up to here, right? Because that crosses there. Nope, that's wrong. Squire, I saw you say something earlier about RC2. So yeah, this is our third week on it, and it's I haven't actually found, like, the first night I found a couple of bugs right away, and I don't think I've run into anything since then. It's like it's like the code base got scared because the bugs I found got fixed right away. But they were all really small things. I was trying to think. I ran into something earlier that made me like suspicious, but I don't know how to repeat it because I'm not really sure what I saw. Okay, I'm about to go into rant mode. I forgot about something that happened on the KiCad forums. Maybe I shouldn't. Let me think about this for a minute. Yeah, I'm not going to because it'd be too easy to find. Never mind. I didn't say anything. Well, I mean, the reality is, I actually don't think you have. Regarding repair and schematics, you know, let's think about things from a practical manner first. If you have a device that is mostly made of custom components, doesn't matter if the manufacturer provides the schematic or not, because you probably won't be able to repair it in most cases. Which is tough, you know, but the reality is the reason things like repair manuals and schematics stop getting made is because they added cost to a product. And it's a cost that if I said right now, would you pay a premium for a product that came with a schematic? I'll bet everyone that hears that question will go, oh yeah, absolutely, I would. And the problem with that response is it's a lie you're telling yourself, because most people, when they finally go to pay for the schematic or pay for the product, are going to buy the cheaper one. It's just the way we are, you know. And it's a trick question, because unless you're actually willing to put the money down right now, it's whatever your response is not valid. It's so, you know, the reality that we have to understand is that part of the reason why manufacturers stopped including schematics is because keeping that documentation up to date and making it available was expensive. And in the race to the bottom, you got rid of the thing that people valued the least. In terms of being able to buy parts from a manufacturer, you know, that's another. Nobody wants to be a direct-to-consumer component manufacturer. Like, that's if your goal is to sell a TV for $200, then keeping a inventory management system and ordering processing system and customer support system so that less than 1% of the people that buy those TVs can buy an ASIC that you used, you know, I sort of get where the manufacturer would come from. Why would they put all that cost into place when there'll be another company that doesn't and offers a lower price product? And that's another one. To me, the best example are cell phones. I'm sorry, but I think the biggest lie people say is, well, I would buy a phone if it supported multiple batteries or whatever. As far as I know, there have been cell phone models on the market since the iPhone that all have removable batteries that have not been very popular and did not do very well. And so if that was such an important thing to have, then how come the phones that provided the feature didn't do very well? Right? And it's, if it really was something that people really wanted, then why did people buy phones that didn't support it? That's oops. You don't need a law. You don't need a law for that. Now that said, I do think that consumable components should have a market strategy for replacement. So things like batteries should have a way to get them replaced, because that isn't something that is easy to, I don't know, maybe what really needs to happen is, like, for certain devices there needs to be a period of time where components are available. Like, and what I'm thinking about is like with cars, at least in the US, I think in order to sell a model car, you have to have components available for a certain period of time after they're no longer manufactured. So yeah, I do appreciate that there are details that I'm glossing over by saying a manufacturer wouldn't want to do it. There are options, but my point is, if it, to me, it's, well, I see it. I see it both ways. I mean, the reason we got to the point we are right now is because people didn't care for a long time, right? I remember having a discussion with somebody who's not very technical, and this is just the discussion we had. He said, he was talking about how we need to bring more manufacturing jobs back to America. And I was like, okay, that's fine. But would you pay more for the stuff you're buying today to have it manufactured in America? And he said, well, of course I would, because all that China can't produce anything but garbage. And I was like, okay, that's two different things. Number one, what I'm saying is, if you're willing to pay more for domestically manufactured goods, that's one thing. Then next is, you have to recognize the quality may not be higher than what you get from, and then I'm just going to use China because it's the largest manufacturing country, because especially today, there's a lot of expertise in manufacturing things. And then this person kept coming back to, but everything from China is crap. And my problem with that statement is that's completely false. The reason he has that perception is because he goes to the store and he buys the cheapest thing he can find, which is generally manufactured in China. And why is it the cheapest thing that you can find? Because it's manufactured with the lowest possible quality in order to save cost. There are plenty of very high quality items that come out of China that have a high price tag associated with them. But this was a case where, this person is saying two things. They're saying, I want high quality domestically manufactured things, but I don't want to pay for them. And there's the fundamental problem, right? The reason we lost domestically manufactured high quality items is because people wanted something that costs less. So now, then you end up with this, and I don't know what shape the curve is, if it's a bell curve or whatever. But, so then you start to have a little bit of choice in the market for some period of time. And eventually there's no more choice left because all you have is what's available, which is the counter argument to my phone removable batteries for phones, right? There was a small period of time where that was an option, and now it is down to one model of phone, and nobody wants that model of phone, right? So personally, and this is just me, I absolutely 100% do not want my phone to have a removable battery. I do not want one sliver of space wasted on the plastic to encase a battery. I would like the batteries to be user serviceable, but I don't want to be able to swap the battery while I'm out and about, and I don't want my phone to be any bigger for that. I would like it to be more readily user serviceable so that after 3 years, I can replace the one that's in the phone. But I do not want to lose 10 or 15% of my capacity just so I can swap the battery halfway through the day. I mean, yeah. So anyway, that's what I want. Okay. See, I've totally forgot to turn the rant thing on. My bad. Sorry. Yeah, you guys are kind of going where I was going with the phone. To me, the phone was actually the really good example, and I thought it would work because this particular person had an iPhone, and I was trying to get them to recognize that, regardless of what you think about the company or even the products themselves, they are high quality manufactured items. I mean, they really are. And so, is just like a Samsung, like a high-end Samsung is, or whatever. I'm not trying to fanboy. I'm just the reality of what it is, right? Countries like China can absolutely manufacture high quality items. It's not that they're incapable of it. In fact, and part of where I thought our conversation was going to go was how I wanted to kind of get to the point that if you actually want high quality items, for high quality mass produced items, there's not that many places that know. Oh, wait a minute. That's there aren't that's a knowledge that's kind of gone away. Huh. Now I got distracted. Something's going on with the multi-units here. They're not. So you can't select a different unit. Oh, here it is. Wait. Okay. Oh. Okay, well, that's one problem. Anyway. All right, enough of that. The rant thing is... Here, I'll turn it on real quick. It's because I don't have a button for it on my thing, so I don't use it very much anymore. And this is why, because by the time I find it, I don't want to rant anymore. So I just have a little thing that says rant. Yeah. So. Oh, that's an interesting way to put it, Commodore. Yeah, I hadn't thought about that. They won the race to the bottom and the top. And for those that aren't familiar with the phrase, race to the bottom is what we talk. I'm sure there's other context for it, but in product management, we talk about it a lot because generally, once you have competitors in a market space, you essentially create a race to get your price to the bottom because everybody wants their price to be the lowest, right? I mean, no matter what you manufacture, you generally want it to be the lowest because lower price is always going to be easier to sell. It doesn't matter if you're talking about fraction of a penny capacitors or $1 million oscilloscope. It's the universal thing. All right, so okay, these need to be swapped. So we got 4, 7, 2, 10. And then over here, we're going to have 9 and 8, 15 and 14. Oh, wow, we get to use the library symbols. This might be the only 7400 series chip in this design that we're using the library symbols. Oh, that's nice. Okay. So, why? So they do 10, 2, 7, and 4. Should actually put the rant thing up there. Now I think about it, on the top of the frame because I'm always on the bottom. This one time at Radio Shack. Oh. Hey, Shark, welcome to the stream. 232 million iPhones in 2012. That's 636,000 a day. Gosh, that is just... Well, that's like when I was at Chemet. We would talk about how we would ship like something like 3... It was something... I think it was 8 billion capacitors in a year. And it was like, not only that, but every one of them had to be tested multiple times. It's like, I was just thinking about that with the phones. Just in general, if you think about consumer electronics, isn't it amazing how rarely you buy something today that doesn't work? Like it has it's non-functional. Not that it doesn't work for what you wanted it, but I mean, like you turn it on and it just doesn't work. It's so rare that happens. Like I remember as a kid, anything we'd buy for electronics as a gift for someone, we would always open it up and make sure it worked because otherwise you'd have to take it back, especially like on holidays, because then it meant it could be days before you got the functional version. So, yeah. Yeah, that's true, Jack. It's actually really true. All the best stuff is made in Japan. I was actually trying to think about how clever that statement between that exchange between Doc and Marty were, because I think we kind of forgot Doc was somebody who grew up in the 40s and 50s, and he was clearly he understood electronics, and so just the fact that he kind of got to watch that whole transition for Japan's technology from, why would you ever buy from them to they have the best. And then, well, I was going to say now it's not as good, but I mean, they're not quite the leader that they once were. Yeah, I'm trying to think how that would... Anyway, I just think it's funny. That's one of those things that when I saw the movies as a kid, I didn't quite get the joke. Other than I thought, for me, I grew up in the 80s, and so to me, any Japanese electronics must be better than anything domestic. I mean, geez, how could it not be? But also, my family, before I was born, lived in Japan. And so, like, all of our electronics were Japanese branded from Japan. Probably until the 90s. See, actually, so like my iPhones, the only reason I generally get a new iPhone is because of the battery. And so what I normally try to do is one time, when they're about 2 years old, I try to get the battery replaced. And then this last time, my last phone, I was going to replace the battery a second time, but it just straight up died one day. Like, just it was such a bizarre circumstance. I pulled it out at a store to use like a loyalty card, and when I went to unlock the screen, I saw the screen start to turn on, and then it shut off, and it never would finish booting after that. And it never got hot. It wasn't. The battery wasn't in terrible shape, but I couldn't even get it to do any diagnostics. It just straight up died. I have no idea what happened to it. But I was mad because I wasn't ready to replace it yet. But all that to say, like, I really feel like with modern phones, modern meaning like in the last 5 years, unless you shatter the glass, I find mine seem to last quite a long time, except for the battery. The battery is the one thing. I mean, just can't get around that. Dumb batteries. That's why I just wish it was user serviceable. I only want to swap my battery every 2 years. Actually, if it was user serviceable, I would change my battery every year. Well, I take that back. When I was traveling, I would burn through batteries pretty bad. And so then I would have done it once a year. But now there's no reason to. It's actually, so I think it was the iPhone 4 or 5. I can't remember which one it was, but I was an application engineer at the time, and I was covering the entire western part of the United States, west of the Mississippi. And so I mean, I don't even remember. Well, I remember a lot. So many of my days, I would go to a customer meeting, and then between customer meetings, I would be on a phone call with somebody while using my phone as a hotspot. And most cases, because our salespeople weren't very technical, also using my phone as the GPS to get somewhere, while using Bluetooth. And I remember in 1 year, I went through 4 batteries. I had to take it and this was back when AppleCare didn't actually have a limit, or maybe it didn't cost me $100 each time I did it or something, which I just expensed to the company. But yeah, I had to get my battery replaced 4 times because my phone would be cooked. Like, I could feel, well, the phone was hot the entire time I used it during the day because I was doing everything on it. And I just cooked the batteries. They were just, it was crazy. And this was all before Apple started doing the throttling and actually monitoring the health of the battery, which probably would have helped, because then they probably wouldn't have as aggressively charged it while I was using it. But yeah, that Anyway, that was a story nobody asked about. I remember my laptop, so probably for 2000 to 2010, it was pretty common for me to have two batteries for my laptops. And frankly, when I went to a MacBook, I didn't need a second battery anymore because unlike Windows, Mac OS understands that when you put it to sleep, it should do things like go to sleep. Crazy concept, I know, right? All right, so didn't I draw the VGC? I did. Okay, so let's start over here. So number 6 is supposed to connect to 33. Okay. So I'm going to just draw some rough lines. I'm going to kind of try to do what they did in their schematic, and then we'll see how these match up later. Okay. And then 30, this HS goes where? So did I follow that right? It goes up here, up here, up here. It goes to 19's pin 6 clock. Okay. All right. So that's going to come up here somehow. Yeah, that looks good. Yes, more pain. All right. Hey, Christian. Okay, so 37 is a no connect. All right. 12 goes up, over. Oh, God, I hate this. Up, over, down. All right. So 12 goes up, over, down, and now it's this line, which is connected to this line, going all the way over to this line, which is the chip selects for those things. God, that looks like that's going to be a mess. Oh, yeah, that's one that I wrote out already. Huh, that's funny. All right, so I'm going to do this real quick. I'm probably going to end up replacing these with labels because this is just a nightmare to read. So then where did this other connection go? It goes from here down to pin 6 on the 155. Okay. Man, this is about to get messy. Okay, where does number 28 go? That goes over there, that goes over there, that goes over there, that goes over there. These all come down here. Oh, we never drew those in. Okay, let's figure this out. So, come on. So you're telling me 15. Oh, that goes way somewhere else. So 12 goes up to number 39. And 35 comes down here. And then this 5 goes to, I guess, whatever, 20, 30. I hate this. I don't like this at all. And then 10 goes to here. And there. Okay. So I do want to do this. I want to go 39 goes to 12. So I have, oh, nope, 39 going to 12. And then this has 35 going to 7. All right, and 30 going to whatever that is. And 29 going to 2. And then those two going there and there. Okay. Here's what I want to do. I'm going to label these right now. So what did we end up calling that? CSS. Right? Okay, and then this will be a not can I, you know, it might be faster. Oh, I can't copy it. All right. So then this will be not a G. This will be GMO. Wait, so then this one is GMO 0. Oh, that's not what I wanted. GMO 0, 1, and 2. Okay. And then 2, and then that connects to the interrupt line. Or internal, external line. Okay. Fear leads to anger, anger leads to hate. Hate leads to smash that like button. Sorry. Oh, I almost said smash that click button. Smash that click button. Okay. So, where does this reset and data signal go? So it comes up around to the not output and the clear for that. I guess 74 is what is that? That's a JK? Or no, that's just a set reset latch. Oh, a 76 is a JK. All right. All right, so then that comes down. Oh, God, I got to follow this again. So it's the second from bottom line. And that goes to U42C. All right, where is U42C? It's right there. So I'm just going to do this for the moment. Okay. And then, so that clock connects to something else. I don't see a dot. Those two we just took care of. J connects to S. Not Q connects to, oh, there should be a wire here. And then this should be not connect, not connect. Ground, J up to here, Q to D. 11 goes down, 3 goes to Q. Reset goes to up here. And then this 11 goes down here, which goes over there. That output goes over there, and then that 6 goes, okay. So I think we got all those covered. Ah! Whoa, that's not what I want to hit save on. Smash that like button. Man, I was actually watching an old video where somebody said that, and I was just like, really? Like, in my mind, that's something that people never actually said, and then I ran across it, and I was like, oh. Anyone that says YouTube used to be better is wrong. All right, so we need capacitor, but let's, I wonder if I could do, wish there was a way to reset the auto placements of these labels. I feel like there should be a way to do that. Where's that? I forgot about that signal. Where does that go? Shoot. We're going to have to go find that. All right. So this is R25. Wait, what? R25. There we go. That's what I was looking for. Oh, I wonder if I reported this one. Check that out. I'm going to try this now. If I change this text to C23 and then click on the part, yeah, the reference isn't changing. I feel like I reported that one already. Or that might be one that I was having trouble recreating. $4K7. Yeah. I remember when having 200,000 subs was a big channel. Actually, I was talking to a potential client the other day. It's been a couple of months, so I really don't mind talking about this now. And they asked me, the question on the YouTube channel came up, and they asked, how did I get so many subscribers? And I said, by making good content. And their response was, no, seriously, how did you do it? I was like, wait, what? And I realized later she was trying to figure out what service I used to buy subs or something. I was just like, geez. I'm like, I never actually even tried to grow the number. The number is what it is. It's not well, I shouldn't say it that way. I didn't employ any tactics or anything like that. I just made videos and promoted them. And that might be the only thing I would consider I did in the early days of AdOhms, like the first 10 to 15 videos. I would spend $100 on the video to have it play as an ad on other videos, which that might have actually been before I had 10,000 subs, because I think that's where I was trying to grow the channel a little bit, but it was through the promotion of the content I made, right? And the idea was, if I use it as an ad and somebody likes it and they subscribe, to me that's just getting the video in front of more people. And I feel like I don't think I did it more than 5 or 6 times though. So I said, because I know the MOSFET video was one of the first ones I did it on. But I wouldn't have spent that much in a year on it. Anyway, it doesn't matter. By the way, that is not a tactic I would recommend using today, because the whole way ads work and everything. And this was back when ads were sort of new. And so there was actually a chance somebody would click on the ad. Okay. All right. I do want to change this to be a different color. So let's go make this a color, because I want this to stand out. Net clap. That's potentially embarrassing. You think? You know, what's really shocking is in the 3 weeks, this is the third week we've been working on this. And so between this and then the time I spent writing up some of the bugs I found and features I suggested, I've only encountered maybe twice that KiCad just straight up crashed like that. So did I commit? No. Yeah, my commit is way older. But I have an idea of where it dropped off, because we're missing this, which is easy. And then these two caps are missing, which actually I might just do an add so I get the labels in the right place this time. Let's make this 22N. And then I'm curious if I change this to, I'm just going to change this to like C10. Yeah, that's still not working. All right. Oh, all right. Hold on. Wait a minute. Oh, you idiot. Well, that was funny. The my camera came unplugged, and anyway, and so the camera was unplugged, so it's been running on battery for over 2 hours, which is crazy because I think before it only lasted 45 minutes. So anyway, sorry about that. Yeah, actually, like a bug like a crash like that one, I'm not even going to bother trying to figure out what happened, because it's too, like, what sequence of events over the last 2 hours would have caused that to occur? And I couldn't even explain to somebody what I was doing at the time. So unfortunately, we're not going to do any kind of report on that because I just don't see it being effective. I do actually have an idea, because there is a commonality here that might be worth going down. So after I say that, something about these text properties and the properties panel, there's something broken. Because the only other time I've had KiCad crash, just straight up crash like that, was when I was playing around with these values. And but I don't know what the magic, I don't know how to report a bug like that, because every time I've reloaded it, everything works fine. So it's like I can't figure out what's even leading up to the problem. So anyway, So we'll make this be like almost the same color that... Well, that's interesting. Why did that change colors? I messed up something somewhere. Yeah, that's not supposed to be connected to E. Yep, that's wrong. Whoops. There we go. Hey, color coding helped save the day.
And there was much rejoicing.
Yay. Something occurred. Yeah, so years and years ago when I was an apps engineer for Agilent, we had this new software framework that ran on our oscilloscopes that helped do automated testing for compliance, for like USB, PCI Express, stuff like that. And it was a very ambitious platform at the time, because up until that point, practically every application we came out with was a custom, was a standalone thing. And so instead, the team developed this framework so that all the compliance programs would be basically built around the framework. And of course, that, especially in the early days, there were a lot of issues that we had to work through, a lot of weird bugs and things. And I remember, I was reading through the bug, we used something like Bug Track, or I don't know, whatever. This was 20 years ago. So I was looking through the bug reports from other people, my colleagues, and they would literally their bug report would be, try to run the test and it crashed. And that was it. Okay. Which test? What was the model of scope that it was on? There was just nothing. And then what frustrated me as a little, I was going to say as a nerd, as if that's changed, is people would just say it crashed. And it's like, okay, but what's that mean? Well, because I remember one time I'm like, well, you mean to tell me you heard the hard drive actually, the hard drive actually crashed? You heard the head hit the platter? Well, no. The program the program exited. It's like, okay, well, did it exit or did it lock up? And when you say crash, did Windows cause a problem, or did you get a blue screen, or stuff like that? It was just crazy to me because everybody just kept saying things like, well, it crashed. It's like, yeah, but that doesn't actually say anything. Because anyway, I'm just why am I getting so worked up about it? It was 20 years ago. It doesn't matter anymore, James. Jeez. They don't even use the stuff anymore. It's totally gone. Okay. Well, I thought we were going to finish tonight, but we're not. Yeah, it's like going to the doctor and saying it hurts. Yeah, actually, that's a really good analogy. It is totally like going to the doctor and just being like, I hurt. Help me. Where do you hurt? On my body. Okay, then. Okay. All right. This next section is going to get hairy. Oh, wait a minute. I might skip this part, because if this is all inside of the modulator, do I really care? Wait a minute. Where's the clock come from? Is E the clock? I think that's what Squire told me. External. It's over here. And then that comes from over here. That's what I thought. So it comes from the modulator. That's dumb. I broke the law. I really don't want to draw this section. That just looks like an absolute nightmare. I'm definitely not redrawing the keyboard matrix. Maybe I'll just insert that as I'll just copy it out of here and insert that as a as an image. I think you can do bitmaps in you can do bitmaps in version 8 now. Okay. You know what I might end up doing now I think about it? We may end up making the modulator a subsheet just because there's no reason for it to be so visible. Maybe that's what we'll do. Yeah, I like that idea. Just make it a subsheet, and then that way it's a little bit cleaner, and then we can take our time on that one. So, okay, cool. Look at all the filter magic, right? Look at all of those L's and C's. I don't know what they do, but I'll bet they form some kind of pass filter. Sometimes. So, I didn't upload it yet. I guess I put it in the Discord. So Discord in the PCBs channel, I have soldered my first set of RF PCBs that I've ever made. And so I'm too tired tonight, but I'll be trying to turn those on tomorrow. This is a 2.4 and a 5 gigahertz design for Wi-Fi using an NRF 7002. Did we design the circuit on the stream? Maybe we did. Anyway, all right. I think I'll be done for tonight. Thanks for hanging out, guys. I don't have anything new yet coming out. I don't know where my next Workbench Wednesdays is. I'm working on a project video. I'm not going to release my KiCad 8 until, KiCad 8 comes out, because that's kind of silly. But yeah, Discord, all that stuff. Thanks for hanging out. Good to talk to everybody. It's great doing this stuff with you. I hope you find time to work on something that you enjoy doing. And if you do, please make sure you share it with everybody. All right. Take care. Goodbye. Have a good one.